Hello, calculus students and general seekers of truth. Let us now return to our examples. We've talked about these rules before. Derivative of a constant, the derivative of a constant multiple, derivative of sums and differences, and we proved the power rule. So now let's apply it. F of t equals 4t squared over 5. We want to find f prime of t. But before I do that, I'm going to separate this just so it's easier to see. This is really 4/5, in other words, a constant, times t squared. Okay? So from our constant rule, we know that we can just pull the constant out here in the derivative and figure out whatever is the derivative of t squared. But using the power rule, we know that the derivative of t squared is just going to be 2, bringing the 2 down to the front, t, and then subtracting 1 from the power. So 2t to the first. So this simplifies to 8/5 t as our derivative. Okay. Let's take a look at a second example. Y is equal to this mess, and we want to find the derivative. And what I'm going to do here is write this notation a little bit differently. This is dy over dx, and this is the same as f prime of x. Okay. But since we're given the function as y rather than f of x, we're going to write it using this notation just so you get a little bit familiar with it. But before I find the derivative, I'm actually going to simplify this function a little bit, or at least rewrite it a little bit differently. So this first part here is really 1/2 times, and this is the cube root of x squared, all over 1, of course, because that's in the denominator. So that's the equivalent of x to the 2/3. Okay. Plus 3x minus 5. Okay. And I'll go another step further. I don't know exactly what to do with this denominator right now, taking the derivative of something that's in the denominator. So we're just going to bring this up to the numerator, and the equivalent of that is, of course, x to the negative 2/3. We still have 3x, and then minus 5. Okay. So now, the reason I write it this way is that it'll make it easier for us to apply the rules that we had before. So let's start with the very first rule, the derivative of a constant. Well, the derivative of a constant of -5 here is just 0, so we don't have to worry about that. The derivative of 3x, we can actually apply the power rule. This is really 3x to the first. So now it's going to become 3x to the 0th, okay. And then the derivative of this thing in the front, we got 1/2 times, and we're going to use our power rule again, negative 2/3 x, and we're going to subtract 1 from this exponent. So negative 2/3 minus 1 is going to give us negative 5/3. And we're still joining this together with a plus symbol. Right. And so to do some simplifying here, what we have is negative 1/3, this 1/2 and negative 2/3, x to the negative 5/3 plus 3, okay, because 3x to the 0th is just 3. Okay. And you can see here we have an addition. So this term, this is like one function, plus 3x, that's another function, plus -5, that's another function. So we're applying the derivative of sums and differences. If you want to take the derivative of the whole function, you just take the derivative of each part and then add them up. Okay. And to find the derivative of each of the smaller parts, we apply some of these other rules, the power rule, the derivative of a constant rule. So there you have it. Dy dx, or f prime, is equal to negative 1/3 x to the negative 5/3 plus 3. In some textbooks and on some multiple choice questions, you might see people flip this and bring this back down. So you might see an alternate version of negative 1 over 3x to the 5/3 plus 3. Now let me make this negative symbol better here. Okay. Negative 1 over 3x to the 5/3 plus 3. All right. So there it is. We can end this video here. Hopefully you get some sense of some basic rules of taking derivatives and how to apply them. As always, ask if you need help. Thank you for watching and have a wonderful day.